diagram of the 5-number summary. A visual diagram of the 5-number summary, which remember we did the 5-number summary on Thursday. If you weren't here, you're going to want to leave a page blank. We glued it in. We had those 5 numbers. I'm going to use those same colors as I used last time. So we used yellow, green, blue, and orange. So if you want to use the same colors, you can, or just pick 4 colors that you like or that are available to you. All right, if this is going to represent our 5-number summary, what's the smallest part of our 5-number summary? The minimum. Good. So this is our minimum. And where do we think that maximum is going to go? At the other end. I like to use yellow for both my minimum and maximum because, I don't know, they just don't need to be too separate. Okay, but now we had a part of our 5-number summary to make 5 numbers, hence 5-number summary. Okay, so we have our minimum and our maximum. What was the next thing we actually found? We had a lower quartile, a median, and upper quartile. Which one did we actually find next after we did minimum and maximum?
What parts do you need to find the lower quartile? You need the median. So can we do that next if we don't know the median? Nope.
So next we have to find that median. And that median is going to be this middle line in that spot. Now our lower quartile and our upper quartile is going to be these other 2 lines. Which one comes before the median? In between the minimum and the median. Is that our lower or our upper?
Lower.
Lower quartile. Which means this other one is our upper quartile. Okay, I did lower quartile in green on Thursday, so I'm going to continue to do it green. And I did my upper quartile in blue, so I'll continue to do that. Now, lower and upper go together. We like to use those words if you're presenting this information to someone who doesn't know a lot about, or maybe who doesn't do stats a lot. You would use lower and upper to describe it so they know where is it in the data. But if you're talking to other math people, other statisticians, what might you use instead of lower quartile and upper quartile? What was our other words for that? Christian, come on. Look back if you need to. What was another name for our lower quartile? Quartile 1. And what was another name for upper quartile? Quartile 3. Good. Now this is our visual, and the visual shows us that even though we have the same percent of the data in between everything, it kind of can spread its way out. So how much is in this first part between minimum and lower quartile? How much is in a quart or a quartile? How much percent of data? 25%, good. So we have 25% of the data here. How much between lower quartile and median? Another 25%. How about median to our upper quartile? 25%. And upper quartile to the maximum? 25%. Now this is called a Box-and-Whisker plot. Which part do you think is the box? Not just the median, that would only be one spot. The lower all the way to the upper. So this whole thing is the box. Hence the name box. And then what would be the whiskers? The spots that go to that minimum maximum that kind of connects, it looks a little bit like cat whiskers. They start here and then they work their way out. So this is a whisker. Remember, whisker is like a cat whisker. They go kind of out. It's a weird word. And we have another whisker over here. Now something interesting is this median, or the box is always going to start with the lower quartile, and the box will always end with the upper quartile. Does the median have to go exactly where it is? Does it have to go exactly here? And every data? No, sometimes that median will be slid over, it'll be a little bit closer to that upper, sometimes it'll look more like it's exactly in the middle. Okay. One other part that's important about our box and whisker plot is this bottom part. What do we call this thing? What do you think this line is with all these little dashes? What if I put like 1, 2, 3, 4? What would we call that if it goes 1, 2, 3, 4, 5, 6?
They might be points, but how are they organized? We maybe didn't even talk about this since the very beginning of the year. What do we call that figure? You know, we have a line and then it has some numbers on it. A number line.
Okay, and that number line is really important because that actually tells us where those 5 numbers are. Where are those 5 big parts? It's as well as when we on a number line, we want to make sure we're counting by something. We might count by 1s, we might count by 2s. But however we're counting, we want to make sure it's evenly. So that way we can really see how this is spread out, because some of our data is squished closer together to be closer than the other 25%. It might be further spread out. All right, so we have 5 steps for this. Step number 1 is to organize the data. When we organize data, we've done this before. We've done this for L1 and we've done this for L3. Normally when we organize the data, we want to go least to greatest, or small to big. Okay, after we organize that data least to greatest, we want to find the 5 number summary. So I actually want to find what is the minimum, what is the maximum, lower quartile, upper quartile, all that good stuff. Step number 3, we're going to create a number line. That actually comes before we do the box or the whisker, because we have to know where that number line is and where we're going to put those points. Don't check your messages. You're in the middle of getting a bathroom pass. All right, then we're going to make our box. And remember, our box is made out of which parts? Our lower quartile, or quartile 1. Our quartile what? 3. And our median. Okay, if you want to color code that with our work, you can. So quartile 1, our median, and our quartile 3. And then we'll create that box. Last thing we do is we make our whiskers. And our whiskers are made out of which parts? Our minimum and our maximum. Good. Dane's got it. Alright, we have one problem that we're going to do with this, and then we're going to talk a little bit about one idea that we didn't really get a chance to talk about. Didn't. Okay, I'm going to roll this down here. Alright, so it says Gabby collected data of the ages people were when they started their first job. What do you notice about this data? What are some ways we could describe it? Can you just fill in where we're at right now? Just start here and then do it. You'll go back and fill it in later. You goof. It's organized. So how is it organized? It goes least to greatest. What do you notice about how old people are when they get their jobs? What's the youngest somebody got a job? 12. Okay, what job might a 12-year-old do? What? Work like on a farm, like do chores? Yeah. What else might 12-year-olds do? Yeah, like work in a family business or something like that. But generally speaking, they can't have like an official job. But you might think that that's when you first started your first job. Okay. What's the oldest that people were when they started their job? 22. That person's real lucky that they didn't have to start a job until they're 22. That's insane.
What sometimes happens at 22 if you haven't had a job yet?
What do you think might do? What would you maybe be doing instead of a job? Just laying around at home?
Yeah, like college. You might get done at about 22. Yeah.
In part of your college loans, you can ask for more than what your college actually is. So some of my friends, they took out a really big loan for the tuition, but then they also took out a big enough loan that they could live off of that money for the year. Now, that's great for them that they're able to not have to have a job during college, but now they have a lot of money that they got to pay back. It's insane. Okay? So in college, I was like, that's the most genius idea I've ever heard. And now as like a 30-some-year-old, I'm like, oh my God, you are probably going to be paying off that loan the rest of your life. All right, what is our mode? Which one happens the most? 17. Why might people get a job at 17 more often than other jobs, other ages? You can start to be a little bit more independent. You might be able to drive yourself to a job. Okay. All right, so let's go ahead and find, it's organized. That was step number 1. Do we need to organize it? No. Nope. Okay, so in step number 2 is 5-number summary. So let's list our 5 numbers over here. What's our first number in our 5-number summary? The minimum. And then what do we find? We find maximum. If we're not going to go in order, that's okay. What were you going to say, Dane? Quartile 1 would come after the minimum. That's okay. If you're just going to list it in order. What comes after quartile 1? Median. Okay. Hey. You can do this part with us. You goof. Alright, and then after median is quartile 3. Alright, so when we actually find this information in our data, this is what we did Thursday, so if you're a guest, this will be a good time for you to get caught up in your life. Okay, what is my smallest age? What was the least amount of age? 12 is my minimum. And if you want to color code, you can. What is our maximum? 22. Okay, now after finding the minimum and maximum, what's actually the next step we do? Which one? The median, yeah. So for median, we're going to go low, high, low, high. We pair them off. I'm going to use underlining for this one. So 12 goes with 22. This 12 goes with 20. 12 goes with 17. 13 goes with 16. 14 goes with 17. 15 goes with 17. If you're not sure, remember you can always count on each side. Make sure you have the same amount of dashes. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 15 goes with 16. Oh, and then we have 2 in the middle. We have 15 and 16 again in the middle, and I want to find out what's right between 15 and 16. And this we could do adding. We could do 15 plus 16 divided by what? 2. Or some of us might be able to think, what decimal comes right between 15 and 16? 15.5. All right, now we're going to find our quartile 1 and our quartile 3. So quartile 1, we look below our median. So below 15.5, we start at this 15, and we're going to work our way down below that. So we're looking at all these numbers below, and we want to find out what is the middle of those numbers below the median. Okay, this time I'm going to just use dots underneath the little underline. So 12 goes with 15. 12 goes with 15. 12 and 15. Uh-oh, we got it again where we have 13 and 14. That one we probably don't need to put in our calculator. What goes right between 13 and 14 if I... 13.5, yep. All right, last one for this one is quartile 3. Oops, don't know. So quartile 3, we're looking at above that median, above the 15.5. So we start at the 16, and we work our way above that. Miss Sarter can, if she's got it open. Sorry, Miss Sarter. All right, so again, we're going to work our way towards that middle. This is the part that you want to make sure you're actually paying attention to how we do this. On Thursday, I had a couple people who were behind in the notes, and then they just put a dot underneath every number, and they're like, why? They're like, they don't get it. The reason why is because we're not just going left to right. We're going low and high paired together. Low and high. Oh, this time my low and high, I still have a number in between, but I have the same number, 17 and 17. Does anyone remember if I have 17 and 17, I could add and divide, but if they're the same number, what am I going to get? The same number, 17. All right, that was step number 2. Jesus. Where's your notes? You don't, do you need it? Yeah. You goof? All right. So step number 2, after we do that was step 2. Step number 3, we're going to create a number line. So in our number line, we have to decide if we're going to count by 1s, by 2s, by 5s. What's my smallest number I have to go to? 12. And what's my biggest number I have to go to? 22. So should we count by 1s, 2s, 5s, 10s to get from 12 to 22? Count by 10s to go from 12 to 22. We could go by 2s. 3s would be a little, I don't really love counting by 3s personally, but if you want to. We could do 2s or we could do 1s. Let's do 2s though, since you said it. So when we count by 2s, I'm actually going to start at 10. I'm going to put arrows on both sides of my number line, showing that it's going on and on. So I'm going to start at 10. 12, 14, so we're skip counting, 15, 16, 17, 18, 19, 20, 21, 22, and then it's just kind of nice just to go a little extra, just to show how that line would continue. So even though we know we're ending at 22, going one more tick mark is like kind of professional. Okay, big thing is when you make your number line, I know right now you're doing it by hand, but make those spaces as close as possible to each other so that you don't have some that are bigger than others. Mine gets a little bit bigger towards the end. All right, step number 4 is to mix. So we're going to do Q1, our median, and Q3. So what is our Q1? What number? 13.5. So where is 13.5 going to be on my number line? So in between 12 and 14. Is it going to be closer to 12 or closer to 14? It's going to be closer to 14 because 13 is in the middle, and then we want to go about a half more. So we're going to try and go a little bit above, and we're going to make a bigger tick line there. And that represents our Q1. And mine's maybe a little bit too much to the right. That's okay. All right, now I want our median. Our median is 15.5. It's going to be between 14 and 16. Should it be exactly in the middle? No, where should it go? A little bit closer to that 16. Yep, good. So again, we want to make kind of a bigger one, about the same length as that Q1, and that's our median. So if you want to label that. All right, and then we have our Q3, 17. Where's 17 going to go? Good. Between 16 and 18, exactly in the middle? Yeah, 17 is right in the middle. Good. So again, one more that's a little bit bigger there, and that's our Q3. So between those three, we're going to make a box. So we're going to connect that Q1, and we connect it all the way to Q3. So we kind of connect those bottoms, and then we connect those tops. And that creates the box of our box and whisker plot. And that's our interquartile range. That's where the middle 50% of people get jobs. The middle 50% of people get jobs between the ages of 13 and a half and 17. Okay, last step is we are going to make our whiskers. And our whiskers are using our minimum and our maximum. So what is our minimum here? 12, so we're going to make a tick mark at 12. And that one we make smaller. So we don't want it quite as big. We want it a little bit smaller. And then we connect that to the middle of the box. And that's a whisker. And then we do the same thing for our maximum. Our maximum is 22. That crazy 22-year-old that didn't get a job until after college. I don't know how they paid for college, but I'm sure they got it figured out. And we connect that to the middle of the box. And there's our box and whisker plot. All right, we have one little idea to talk about real quick. And this is an outlier. Outlier. What do you mean? What do you think an outlier is? If you're an outsider, what does it mean to be an outsider? Yeah, you like don't fit in. You're kind of looking at things from the outside. You're not really part of like the in crowd. So an outsider is somebody like looking in. An outlier is a data point that doesn't match, yeah, or doesn't follow the trend.
It lies outside. Got that compound word there, outlier.
Outlier. It lies outside, so it doesn't follow the trend of the data set. All All right, so as we look at these data sets, we're going to decide if there's an outlier, a number that doesn't really belong, that doesn't match, that doesn't fit what's happening. So in this first one, we have 5, 26, 12, 9, 7. Ignore that. Okay, and if that's hard for you to think about, maybe think about it as ages. If you're having a birthday party and you had a 5-year-old, a 26-year-old, a 12-year-old, a 9-year-old, and a 7-year-old, is there one that doesn't really belong? Which one? Yeah, the 26 doesn't really belong. It's kind of goofy. It's really far out there. How far is it between 5 and 7? Smallest to the next would only be 2, right? How much is it from 7 to 9? 2. What about 9 to 12? 9 to 12? 3. But then to go from 12 to 26, how big is that jump? 14 away from the last one. So, because that makes it an outlier. So that 26 is an outlier. All right. Which number doesn't belong? So normally outliers would either happen at the smallest or at the largest end. The outliers normally don't happen in the middle. So we're looking at kind of this 2 and 9. Is 2 way smaller than everything else?
How far is it from 4?
2. It's not like super small compared to the others. 9 way bigger than the others?
How far is 9 from 7?
It's only 2 away from 7. They're not that far away from each other. So is there anything that is like so far out of reach that's like crazy? No. So in this case, are there any data points that don't follow or that don't match up? Nope. So this one, there are none. These all are within each other. They're close together.